Today we're going to start chapter 6 where we are going to be looking at properties of exponents and also a little bit of scientific notation that you may have seen before in science class. All right, on the top of your note sheet, to simplify an expression containing powers means to rewrite the expression without parentheses or also without negative exponents. We don't ever want to leave our answer with negative exponents, just not good math notation to do that. All right, so getting into the different properties of exponents that you see on your note sheet there. The first one, product of powers. When multiplying monomials, you want to add their exponents. There's a couple examples on your sheet. This first one, we have x squared times x to the third power times x to the fourth power. We want to combine those into a single term. Now, if you think about it, x squared means we have two x's. X to the third means three x's. X to the fourth, four x's. How many total x's do we have? Well, if you count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9 total x's. So this would be x to the ninth power. It also works if you just add their exponents. If you take 2 plus 3 plus 4, you get 9. So you want to add exponents when the base number, the big number, the x in this case, is the same. All right, second example, same thing. Anytime though you see a variable like this m here with no exponent, we know it's always 1. So this one would be 1 plus 2 or m to the third power. So add exponents when their base number is the same. All right, second property, power of powers. Whenever you have a power to another power, you want to multiply the exponents. So when taking a power to another power, multiply the exponents. The key thing to notice here is, like in this first example, you see this power of 4. It's just hanging out by itself. Right now it has no base number. So whenever you see a power like that, that's when you should be thinking multiplying. Okay. So on this one, we would get y squared power of 2 times 4. This is going to equal y to the 8th power. Now, again, why does it mean that? Why do you get that? Think about if you have something to the 4th power. That means you're multiplying 4 of the same things. So if we have y squared, y squared, y squared, y squared, 4 of them, that's what it means to have something to the 4th power. Just if we just use the last rule we had and add these up, you get the same thing, y to the 8th power. So that's why it turns into multiplying when you have power to a power. All right, in the second example, you see we have more than one thing. If you have more than one thing and everything's being multiplied within the parentheses, everything needs that power. So on this one, everything there needs the power of 3. So the 4, number 4 gets the power of 3. This x squared gets the power of 3. Now here's power to a power, so we want to multiply x to the 6th power. Y does not have one, so y is going to be cubed, or to the 3rd power. That's the answer. If we got a number to the power, though, we do want to simplify that. So if we go on our calculator and figure out what 4 to the 3rd power is, we should have that. Remember on your calculator to do bigger exponents, you want to use this caret key button right here. It's on your calculator, so hit 4 to the 3rd power, and then you can evaluate it, 64. So this would equal 64, x to the 6th power, y to the 3rd power. So numbers, if there's a number to a power, you should simplify it. All right, next property. It's called quotient of powers. Quotient of powers, when dividing, quotient means to divide. When dividing monomials, you subtract their exponents. When dividing monomials, subtract their exponents. All right, first example. We want to divide m to the 5th divided by m to the 11th here. So what do you get when you take m to the 5th divided by m to the 11th? Really, what you're doing here is subtracting. Remember before when we multiplied, we said we want to add, so it just makes sense. If we're dividing, we want to subtract. Now, you're basically canceling out here. On top, we have 5 m's. On bottom, there's 11 of them. So if you would cancel out, we could cancel out 5 up here with 1, 2, 3, 4, 5 down here. How many does that leave? 1, 2, 3, 4, 5, 6. So the answer, there is 6 m's left over. Now you got to be careful. Where do we have the m's left over? Is there more m's on top or is there more m's on bottom? You can see there's more in the denominator. So when we're done, we get m to the 6th power, but it's on the bottom. It needs to stay on the bottom. Everything on the top is gone. Anytime everything in the top cancels out, we leave a 1. So the answer would be 1 over m to the 6th power. Same thing on the second one. We got a to the 7th over a to the 3rd power. We can cancel again. Here, 3 a's would cancel. 7 minus 3 is a to the 4th power. Here, there's more a's left on top. So you can put it over 1 if you want. When it's over 1, though, that's just dividing by 1. You don't need to. You can just leave your answer as a to the 4th power. So that's quotient of powers. All right. Negative exponents. We talked about this earlier. In the beginning, we said we always want to rewrite our answer without parentheses or negative exponents. Here's why. You cannot leave negative exponents in a final answer. To get rid of a negative exponent, you move it to the inverse or opposite side of the fraction. All right, what does that mean? Well, let's look at this first problem, or first example, 3a to the negative 5th power. We don't want to leave our answer with this negative exponent. So what we're going to do is move it to the other side of the fraction. Now, right now, this is not a fraction. So what we're going to do is make it into a fraction by putting it over 1. Then we're going to take this term right here, the part that has the power of negative 5, we're going to move that to the inverse side or other side of the fraction. By doing that, it turns into positive. So this would now equal 3. 3 stays on top. We haven't moved this 3 at all right here. But the a to the 5th power, a to the negative 5th power, by moving it down to the denominator, it turns into a to the positive 5 power. Now our answer does not have any more negative exponents. Okay, second example. We want to simplify this one, 2 over x to the negative 3rd. Again, the part with the negative exponent, this time it's in the denominator, but we still want to move it to the inverse side. We're going to move it up to the numerator this time. And now it equals 2x to the positive 3rd power. Nothing's left on the bottom, so you can put it over 1. You don't need to, again, though, write your answer when it's over 1. You certainly can leave it. You don't need to. This would just equal 2x to the 3rd power. Dividing by 1 is just equal to what's in the top. All right, final one. This is the easiest property of exponents. Anything to the 0 power is always 1. Anything to the 0 power is always 1. You could try it on your calculator. Take any number to the power of 0. Anything's going to equal 1. So in this first example, you have all this stuff here being taken to the 0 power. Answer is 1. Now be careful. On this second one, second example, what's being taken to the 0 power? Only the x's. So x to the 0 power will equal 1, but it's multiplied to this 5. So what we have is 5 times x to the 0 power is 1. So here the answer would be 5. The 5 is not to the 0 power, only the x's. So whatever's taken to the 0 power, that equals 1, and then multiply to whatever's left over. Okay, on your sheet, there's also a couple examples where you kind of have to combine some of these properties. Let's try number one. Now remember, when we get done, we don't want to leave any negative exponents. So on this one, we're doing some multiplying. We got these parentheses. We don't want parentheses in our answer, so we want to combine. Everything here is being multiplied, 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 multiplied. Everything's being multiplied together. So we want to multiply like terms together. Let's start with numbers. 3 times -4 will give us -12. Now let's combine our x's. We got x squared, x squared. They're separate monomial terms. We want to add their exponents, x to the 4th power. Now let's do our y's. We got y squared, y to the 4th. Again, add their exponents, y to the 6th power. And that would be our final answer. We don't have any negative exponents. We are okay. All right. Let's look at the next one. And the next one, we do have some negative exponents. So whenever you have negative exponents, move it first to the opposite side of the equation, or inverse side of the equation. So this one would equal, this first one's negative. Let's move it to the bottom. It would be a to the 3rd power in the denominator. We're moving it down to the denominator. The next term, we don't need to move it. That's going to stay in the numerator. This one's positive. That's going to stay in the numerator. This one's negative. We're going to move it down below. Okay, so we've gotten rid of our negative exponents. Now we just want to see, does this simplify at all? Yeah, we can do some cancellations with these two a's here. We got a squared on top, a cubed on bottom. If we subtract, there would be 1a left. And the 1a that's left would be on the bottom. So this would be the simplified answer. All right, we'll try some other ones in class. Flip to the back. There's one more thing we're going to kind of talk about here today, and that is scientific notation. The form that you usually write numbers in is in standard notation. When you have really big or really small numbers, though, we use something called scientific notation. And you may have seen this before in science class. Anytime you write in scientific notation, it's written in this form, a times 10 to some power, where a is going to be a number between 1 and 10, and n is always an integer, which means a whole number. All right, this first example, they want you to figure out the density of an object, and density is found by dividing the mass of a substance by its volume. A sample of platinum has a mass of 8.4 times 10 to the -2, so that's the mass. And we said it's mass divided by volume for density, right here, mass divided by volume. So we want to put the mass on top, which is 8.4 times 10 to the -2. And the volume is 4 times 10 to the -6. Use this information to find the density. So we're going to divide that. Well, just like we did on those other problems, we get some negative exponents. Before we divide here, let's move those around so they're not negative anymore. So this would be 8.4 times 10. Moving this one up to the numerator would become +6 over 4 times 10. Moving this one down to the denominator makes it +2. All right, so let's take care of our numbers. If we divide the two numbers out, 8.4 divided by 4 leaves us with 2.1. So the answer is going to be 2.1 times, now we do our powers of 10. We got, it's going to be a power of 10. If we subtract the exponents, 6 minus 2 is 4, and there's more left on top. So the answer would be 2.1 times 10 to the 4th. Now this would be the density in, let's see, it would be in kilograms per cubic meter. So that would be the density of the object. All right, tomorrow we'll take a look at some more of this.